Okay guys, so in this task we'll be doing the more malloc and free function, right? So let's get into it. First we would go, I think this resource has been given in the previous stuff. Do I cast the result of malloc? Okay, you can watch this guy as well, and then you should probably learn about calloc and realloc. Okay, they are also reallocation is to reallocate another a block of memory, so you can still use malloc to do that. Reallocation is just probably you reallocated something in the heap, the memory before, and then you want to increase the size. Okay, so you use the realloc. And then calloc is another way of allocating memory. Okay, and if you man calloc, for example, I man calloc. Okay, you see, let's see. Let's see if it's gonna. So the malloc function. Okay, I think this one is talking about malloc free. So the calloc function allocates memory for an array of n member, right, elements. So the difference between malloc and calloc is that calloc allocates several blocks of different blocks for different elements, while malloc will allocate just one single block. Okay, so that's basically the difference, but let's just get into it and we'll be able to solve questions with them. We will not be using them directly, but we'll be using malloc to write some functions that act as calloc and realloc. Okay, so let's get started. So I'll just go through the quiz for you so you can see that as well. So for the quiz, we open this and then we have the first question. So it says that where does the space reserved by malloc, like where is it? Is in the heap, not the stack, right? So the heap, right? So the next one, to allocate memory for an array of 10 integers, right? So it means that it can save 10 ints, right? So you use 10 times the size of that int, or 10 times 4, but because on a 64 bit is always 4, so 10 times 4 will work, right? So yes, so that would be that. So the next question, what is wrong with this code, right? So if you look at it, you see that there is no comment, right? And then there is no header file, right? So the malloc can fail, so we check its return value all the time before using the pointer term. So this one is saying that, okay, after we declare a pointer to malloc, right, and then we need to specify that, okay, what if my malloc fail, it should return null, right? So this is that. Okay, and you can do this. Can you do this? No. Why? Because if this is a string, right, you've not declared any memory for it, so why are you freeing what you didn't declare? This one is on a static memory, right? It's not on the heap, so you can't free it. You're not the one that created it. Okay, so you can do this. No, you can't free like this, right? You free a pointer, not the string. Malloc returns a pointer true. Malloc return an address true because the pointer is an address, right? Pointing to an address. What would what will you see on the terminal? So on the terminal, you should print a segmentation fault. Why? Because int pointer is not pointing to a variable yet. So when it's not, it's going to give you a segmentation fault, right? And then the last one, if I want to copy the string best school, right? So they are just trying to say how many space will you need to allocate. Best school is 11 plus the null, you allocate 12, right? So 12 size of best school, right? Probably best school has the size, and then the string length. This one will be 11 plus 1 is still 12. Okay, so that's that. You can do this. Yes, why? Because this one is the condition to check if the null, if the memory you allocated for this guy is 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 actually allocated or not, right? So let's get into the task and see what we can do. So write a function that allocates memory using malloc. Okay, so we want to use a malloc to allocate a memory, and this is the prototype, right? So first I would I haven't created the, so we first create our directory. So let me create this guy. So I'll cd into ALX low level, right? And then I'll make the directory this. So I'll cd into this. I'll vi my readme .md, right? So I can say more memory allocation using malloc, right? Line doesn't matter. Okay, so we'll have a main.h. Okay, and then the main.h will say if not defined, you should what? Define it. Right, and then we should end if defined. Right, good. So that's been said. Then we can have our prototype for this guy first. We have a prototype for this guy, so we'll put it there once and for all. Good. So we're done. So far we have these two files. Then we'll create our testing guy, which is their main.c, 0 main.c, to test our function that we'll be writing. Okay, up to this guy. So vi 0 main.c, paste this guy there, escape. Alright, so far we have these three files. Right, I want to create a git ignore in order to not pass anything that ends with main.c. Okay, and also our executable for these files. So the executable for this one is a, so I don't want to pass a as well for now. I don't want to push it to GitHub. So far we have these 4 files, right? So the next thing is our actual code. So we'll go into it and then we'll explain what we are doing. So what we do is 0 malloc checked.c. Alright, vi 0 malloc check.c. Good. So we'll create our header file, which is as header file. We include our main.h. We include our standard library because we are using malloc. Right, and then we'll document it. Don't forget, I need to copy this guy, the prototype. We need it. So I can put down shit. Let me put this on here like this. So let's delete that one for now. So the name of the function is malloc underscore checked. And what is the function of this function? So write a function that allocates memory using malloc. Okay, it's going to allocate memory for an unsigned int b. Okay, so it's just going to allocate memory for this. Return a pointer to the allocated memory. If malloc fails, the malloc checked function should cause normal process termination with a status value of 98. Okay, so if it fails, you just terminate the process and give you an error called 98. So this is similar to what we've done before. So the main function is just to allocate memory using malloc. So this one is just to allocate memory using malloc. Okay, so any arguments just b. So I can come down and say at b is the input int, and then it's going to return nothing. So since it's not returning anything, we can just put our return void, right? And then we end it. So and then end. Good. So next thing we're gonna do is, because malloc returns a pointer, right? So pointer to a void, right? So naturally it returns a void pointer. So the pointer, I can call it pointer, right? Okay, and then I'll end it here, and then I'll give my space. So I'll allocate memory to that pointer and say pointer equals to malloc, right? Okay, and then I want to allocate memory to what? The size of b, right? To b. Okay, and that will be all. And then I want to make a condition for if it fails. So you know how we use our if statement, and then I can use my block layer, right? And then our return, I just say you should return our pointer ptr, right? I think that's what we were told here. So it's going to return pointer regardless of this return type to be void. Okay, so what we're going to do, we'll say if our ptr is equal to null, right? So if our ptr is equal to null, that is, if the memory was not allocated, maybe there's not enough space to allocate this memory, then it should cause an error, right? So it should exit. So this is a function, a exit function, and then we'll put 98. When it exits on 0, it means it's successful, but when it exits on any other number except 0, it means it is not. So it's going to print out that error message. Okay, so let's quit it. Let's clear the screen. Okay, so let us see what we just write. 0 malloc. Okay, it's checked. So let us compile and run and see if we get our answer. Right, so when it is being compiled, we get this value, right? Okay, so I think that's it. Wait, what happened here? So when they echo this guy, it print out 98. That's so funny. Alright, so okay, so let me see. More start of malloc. Let me see what's going on here. Status of malloc failed. No such file or directory. Oh, I think I overcopied the compilation. It's supposed to be from here. is this guy. Okay. Alright, so it's supposed to be like this. Yeah. I was wondering what was happening. Okay, so I've pressed you now. Why are you still delaying? I think this thing is hanging again. Maybe I might need to reload it. So let's go back to CD ALX low level. And what was the name again? 0x0C, I guess. So MS. So let's run our A. So we got this, and I think that's what we had there. But we had 30. So it's kind of different from what we have. Let me see. 0x1E. It's kind of different. Anyway, what I'm going to do is let me stick it out and see what git commits and give it create what's it called, create memory, allocate memory or create memory, memory, am I correct, using malloc, right, and git push. Let's see if this guy works. So oh, it worked. So why are we getting different compilation values? How are we getting different compilation values? I don't know. But anyway, I think that should do. So we have that. So let's go to the next one. So basically, like I just said, it's just allocating malloc memory for an int, and then you free it if it is null, and then you make it print out. Instead of returning null, it should exit 98, right? So that's what we just did there. So for this one, which is the second one, we have this. So what I'm going to do is, this one will concatenate two strings, and you know what concatenation is? It's like joining two strings together. But the problem is, we have the first string, we have second string, and we have unsigned int here, n. So what happened is, we are concatenating both strings, but we want to add this guy to this, we want to add this amount of n of this guy to this guy. So if this one is 15 words, right, 15 letters, and this one is 15, and this one says 5, it means that we are adding 5 out of this guy to this guy. Okay, that's what we are doing. We've done concatenation in the last one, so this one is just in another dimension, and we want to allocate memory for that space. So we'll be considering this guy and this guy in order to allocate our space. Okay, so the return pointer shall point to a newly allocated list which contain s1 followed by the first n byte of s2, as you can see, and not terminated. If the function for you should return null, right, if n is greater than or equal to the length of s2. So if n is greater than this or equal to this, then use the entire string of s2. So if n is 100 and this place is just 5, we should just use all the 5 here, right? Okay, or if it is 5 5, we should use all the 5 as well. So if null is passed, treat it as an empty string. So if this guy is null, we should treat it as this guy as empty. So we are just going to print out this guy. Okay, so that's what we're going to do. So we copy this guy and we go through the code. Copy, vi main.h and paste it here. Good. The next thing is our tester, which is one main.c. So copy this guy and what? Okay, good. One main.c. Alright, so we'll escape that, and then what do we do next? We what's the executable? The executable is called one string this concat. So I'll put this one in my git ignore. Right. Sorry. Okay, so I'll create my file and then I'll get the other file. So this guy, right, and then the other file, I said the file. Why do I keep saying that file? The prototype. Alright, so go to the home and then we can include, hey, what am I doing? Control L. Anyway, it's up to you. Let me replace it. Good. Boom. Yeah. Include our main.h. We'll include our standard library .h, and then we'll start with documentation, and then this one is called string underscore n concat. So concat, is it concatenate? Am I right? Is it concar? Yeah, okay, concatenate two strings when while second string is an n value. So what are the S1? We have at S1 string 1, we have at S2 which is string 2, and then we have n, which is the number of elements to concatenate from S2. Okay, and then we have a return, a character. So it's going to return a pointer to the new allocated main node, and then that will be all. And then yeah, we're back. So what we do next is we'll create size underscore t, which is unsigned integer, and then we'll give it ijk. Alright, and then the pointer to the where we'll be storing it, let's just call it s, right? Good. So we just created ijk because we need it for some loops, right, to add them together, get the string length and all that. Okay, if we'll be using the string length method. So what we'll do next is we'll say if, remember, if our s1, we want to know if our s1 is null. Okay, so if our s1 is null, we want to know. And then so let's continue. So we'll say if our first guy is equal to null, then what should you do? You should just make I equal to 0. Okay, so you understand that later. So we can have else you should we'll have a for loop, right? Else, so we want to get the length of s1 now, right? So if it is null, it means we should treat it as an empty string. I think that's the if n, where is it? So if null is passed, we should treat it as an empty string. So if this guy is null, so if it is not null, it means that there's something inside, right? So we want to get the length of that something. So we'll say I equals to 0. Okay, so s1, we can use this guy to iterate through what is inside at index I, that's at index 0, as far as and then we can say this, and then I plus plus. But I think this guy we can give it to not equal to, as far as not equal to null. I think this would help us get the value not equal to null. Or should we just leave it like this? Let me say as far as not equal to null. So if this doesn't work, we'll remove this not equal to null later. Alright, so we'll check for s2 as well if it is the same thing, right? So we'll say if our s2 is equal to null, we should treat it as we should treat it as let me just to save space, we should set j to 0 as an empty string, and then else as well. So we'll get the length of this guy as well. So we'll say a for loop, and then we'll say j equals to 0, s2 at index j. So this not equal to, I might remove it later if you have any error, not equal to null, j plus plus. Alright, so that would we'll get the length, and then we'll treat all our null as not a null, to treat it as an empty string, right? So go like that. So let me just create some space. Great. Okay, so we want to know if this j is now holding the length of our s2. Okay, so if s2 is 5, we want to know if 5 is greater than n. Okay, because we need n to be probably greater than s2. Okay, so if our j is greater than n, then what should we do? Okay, then if our j is greater than n, then we say our j is equal to n. We'll pass the value of n to j. Why do we do this? So if our j is 5 and n is let's say 2, okay, so we are passing 2 to j now because we want to only print 2 of this guy. You understand? So if this one is 5, this one is 2, we are passing 2, this 2, we are passing it to j because we only want to print 2 out of this guy. Okay, so that's if it is, but if it is less than, then we'll just print n. Okay, so we'll then say our pointer that we created will now allocate memory and say malloc, and then end it like this, and we'll say size of char. We want to allocate char times, let's open bracket, parenthesis, brackets. So we'll say our I, the length of our I, plus the length of what? Our j now, right? Plus our null at the end, right? So we want to allocate memory for it. Okay, all right. So that's what we do. So we then say if we want to check if this guy is allocated, right? So if our s is equal to null, that is, it's not, it didn't allocate space, right? Then it should return null. Okay, so this guy should be in brackets. I think that's the end. Good. So that's that. So the next thing we want to check is let me see. So we'll iterate through in order to combine them now. So we'll say I think we've used ij, it remains k. So we'll use k equals to 0 now. Okay. So as long as k is less than I, so we want to give s the value of k first, and then we'll give the value of I first, and then we'll give it the value of j, right? And then we would add null at the end. Okay, so what we do is k, yes, this guy, and then k plus plus, right? Okay, so wait, this 4, is this supposed to have, okay, I'm not sure. Okay, let's continue. We'll get the error when we are done. All right, so that what we want to do here, right? So then say s at index k, which is at index 0. We then pass it the value of s2 at index 0, right? s1, sorry, x1 at index 0. Okay, at index 0. So, and then we'll increase I as well. You don't need to increase I. So this one would keep increasing. So s1 at index 1 we pass to this guy at index 1, at index 2, like that. Alright, so we are good. And then we'll have another for loop for the second one. So we'll say we'll use our k as well. K equals to 0. Okay, k is now less than j, right? As long as k is less than j, k plus plus, and then we'll have the same thing, and then we'll say our s x at index is going to be now k plus I, because if I is 7 already, so 0 plus this one to start from 7 and then add up to it, and then we'll say it's equal to S2 at index K, right? Yes. So at the end we'll then add a null to it, so it will be S at index I and J, I plus J, right, is equal to, we'll pass in null, and then we'll return S. So we should have so many issue, so we just rectify the issues, right? So I think this all. So we can escape. Let's first Betty. Let's see if we have Betty issue. Okay, we have trading white space at 22 and 29, and that's all for now. 22 and 29. So let's set number 22, 22, 22, 22. Yeah, this is the white space, and 29. So let's use our set list to see. Let's see, 29. Okay, 29 doesn't seem to have white space, so we seem not to have white space. Let me see. So let's see again. Trailing whites. Okay, trailing statement should be on the next line. All right, that's 22 and 29. I thought it's trailing white space. So let's see 22 and 29. 22. Yes, this guy, I guess. And is this guy that was saying? I'm not sure. I think the yes, I'm not supposed to have. So let's clear it. So probably we'll put the semicolon down. Suspect put indent at 22 and 29. Yeah. So what I'm going to do is I'll just come down here and then do this, enter. I'll put this guy here. And I think that should solve the problem. Oh, sorry. I wanted to quit it. Okay, that solved the problem. So let us compile and see. So to compile, we might have some errors. I think that null that I added to the length might give us some issue. Okay, it is S1 because I never had SI. It should be S1. So let's click 22. Let's see 22. Let me just set number. Okay, it is here. All right. Yeah, it is S1. Yeah, and let's compile. Okay, compiled. One string concatenate best code. That's cool. Okay, let's see. So let us clear it and ls. Alright, so let's git add, let's git commits and say it should concatenate two strings. Let's just leave it at that, and then let's git push it and check. I hope this one works. Okay, good, we worked. So we go to the next one. So the next one, it says write a function. Okay, so this one we are using the MALLOC function. So MALLOC function is different in the sense that it allocates blocks of MALLOC will allocate one block and then you can save stuff inside, but this one will allocate this number of block. So you pass in the number of block and you say, okay, I want each block to be able to save an integer. So it's going to allocate, probably if this one is 5, so it's going to be allocate 5 block that can save an int. Okay, so that's how MALLOC works, and then we're going to use this guy to do it. So let's just go into it and start. So we'll do this, we'll clear, we'll main.h, and then we'll paste this guy, insert mode. Alright, okay, good. I undo that part. So what I'll do next is my test as usual. So to main.c, I think it ended here. So copy, let me just be sure. Oh, it didn't end here. Still long. So to main.c, why is this guy long? Alright. Alright. So what is the executable called? To MALLOC. We'll copy it, vi.gitignore, and put the guy there. Alright, so the real file, and then we'll get the to MALLOC.c, get the prototype. I'm supposed to paste it, paste. So let's get the prototype. So get this guy again. So I'll paste this guy there. Enter, enter. So I can start coding. Include my main.h as usual. I will include my standard library.h as usual. My documentation, it is returning a void, is called _MALLOC, right? And then this one is to allocate for an array. Allocate memory for an array. Right, so we are going to collect 2 parameters, which is the n member, right? Number of block memory, size, and then this one will be size of the data or the element, which is an int for this tab, and then we'll return a void pointer. Okay, sorry. So remove this guy. So we have our character P. Okay, because it's an array of character that we want to allocate. So the calloc function allocates memory for an array of these elements, okay, of size bytes each, and turns the pointer to the allocated memory. The memory is set to 0. So the difference between calloc is that another difference is that when you allocate memory in malloc, a chunk value is inside that memory that you allocate, but calloc, it is allocated with 0 value, so you have to do that yourself. The memory is set to 0 if n member or size is 0, then calloc returns null. Okay, so if there's no block, it means that it will return null. If malloc fails, then calloc should also return null. So you're using malloc to act as calloc, right? So we are returning a pointer to this guy, so let's call it pointer P. So an unsigned int, so we'll call it size underscore t, and then we'll call it size underscore t, let's call it I. So we just need I, is okay. So we'll say if our n member is equal to 0, right, it should return null. And also, or there's our or if our size is also equal to 0, it should return null. That's that. Okay, so we then allocate the memory. But this time around, instead of using size of, because this one takes block and multiplies it with the size, probably 4, right? So it's just one size, so we use that number, so it's going to be n member times, so this one is the number of block, right? Okay, times, and then this one is a definite size, so it's going to be just times size, right? So I think that should be that, and then we'll create if it didn't allocate, right? If our p is equal to null, then it didn't allocate, then it should return, it should also return null, right? So we then print out, we iterate through this stuff, we initialize the value of p to be 0. That's what we want to do now. We then say I equals to 0 as long as I is less than the value of n member times size I plus plus, right? And then this one will now have this. Okay, so we then say our p at index I, at index 0, for example, should be initialized to 0. Okay, and then it should return the pointer. down pointer. Alright, so I think this one should work. So we'll Betty it and compile it. So let me Betty to MALLOC, and then we compile with missing initial short description of MALLOC. Probably we misspelled MALLOC there. MALLOC. Oh, sorry. We're supposed to use dash. Right. So, okay, good. So let us check this guy. Where is it? Compilation. So to compile, we start from GCC. Sorry. Copy it and do this. Alright, so we'll say this and then we get this value. So let's check, is that what we get? OX21 at the end. Okay, good. So OX is, yes, good. So that's that. Then we clear our screen. Git commits, allocate memory for an array. Git push. So we then check our code and then let's see, should be correct. This guy is wasting our time. Okay, while that one is doing, let's continue doing this one. So we copy this guy into our main.h. Right. Good. Still checking. Alright, so the next thing is our 3main.c. We'll copy the content. This one too is long. The 3main.c. Alright. So the next thing is our executable is this guy. Will pass it to our git now. Okay, yes, and then file name, sorry. Let me drag this guy. Our file name is what? 3arrayRange.c. And then we get our prototype. So let's see if that one is done. So it's checked, that's checked, so it's correct. And thank God we didn't waste time. So let's copy this guy and paste it, insert, home, enter. So we include our main.h, we include our standard library .h. Then we start our documentation. It's called array underscore range. So what are we going to do here? it says that a function that creates an array of integers, right? So we have minimum, we have maximum. The array created should contain all the value from minimum included to maximum. Okay, so order from minimum to maximum, blah blah blah. If minimum is greater than maximum, return null. Okay, so we'll go into it and then would so create an array of integers. So this one is just to create an array of integers. Alright, so the next thing we want to do is we'll do our minimum, and then minimum value, and its maximum value. You should return a pointer. You should return int pointer to the allocated memory, right? And then that should be all. We'll come here and then something like this. So the first thing I'm going to do is int I and int, let's do L for now. Okay, so I want to do for my pointer, right? Good. So he said if our minimum is greater than our maximum, that we should return null. We should return null. Okay, so that's what it says. All right, so let's declare our L. So maximum minus minimum plus 1. So what we are trying to do is we are trying to create an array, and then we want, it says that the array created should contain all the value of minimum, okay, excluded to maximum. So we want to create all the value of minimum that is not inside maximum, and then we would add our null to it. Okay, so that's what we want to do. So we'll allocate a memory for it, and then inside the memory we will say size of an int times the length, which is L for length, right? So, and then we'll check if our allocated memory is allocated, or so if this one is equal to null,